From Studio A at the USC Annenberg School, this is Taiki Jones, your host from the Paradigm Podcast. Today we're speaking to Bhaskar Krishnamachari, a professor at USC who holds joint appointment in the Department of Electrical Engineering and Computer Science. He is also the director of the Autonomous Networks Research Group, where he conducts research on the Internet of Things, robotic networks, and blockchain technologies. Bhaskar is a prolific academic writer and has co-authored more than 300 articles on algorithms and protocols for and applications of technologies, including wireless networks, distributed systems, artificial intelligence, and machine learning. In our discussion today, we'll be focusing on what he has called the ABC of emerging technologies. The A standing for AI, B for blockchain, and C for connected devices. With that, please welcome our guest, Bhaskar Krishnamachari.
Could we start by just having you introduce yourself so that our viewers
can
get situated?
I'm Bhaskar Krishnamachari. Mm-hmm. I'm a faculty member here at USC. I came in 2002. Before that, I did my PhD at Cornell. Mm-hmm. And my research is quite broad these days, but touches on the Internet of Things, distributed computing, blockchain technologies, as well as applications of AI and machine learning.
And may I also ask, how did you, like when you were a child or whenever it was the first time you got interested into these, how did you get interested into technologies and how did you learn programming, coding, and all that?
That's a good question, actually. I think it must have been like middle school. I was in India, 7th grade. We had a computer lab at my school, which this was late 80s, early 90s. So I remember just really being fascinated by computers and what they could do. We had these BBC microcomputers in the lab. And just fun experiences. Even sometimes all we did with the computers was just create and play games. But you have to get started with technology somewhere. That was my start, I think.
Wow, because late 80s would be right after, well, Macintosh was 84, so I guess it's picking up right now.
This was a product, the one we were using was called BBC Micro, so something from UK, I guess, yeah.
Oh, cool.
Yeah.
Oh, BBC, I see. So our discussion today, I think we agreed that we're going to talk about an article you wrote, the ABCs of emerging technology. So if you could start off by explaining what that is and why you chose ABC, all of that.
Sure, yeah. This is a Medium post that I wrote, and I was referring to the ABC of emerging technologies as kind of a way to get started to think about, how do I organize all of these things that are happening in the world in terms of new technologies. And so the A stands for artificial intelligence, B stands for blockchain technologies, and C for connected devices, or what sometimes people call the Internet of Things. And so in this article, I was just pointing out that if you kind of look around the landscape of what's happening in engineering, a lot of the innovations that have emerged in the last several years have had to do with these digital information technologies. And each of these three emerging technologies has kind of a complementary role to play, where you can imagine the data being collected from connected devices and communicated between them. We can think of blockchain technologies as helping to store and process some of that data, as well as communicating value over the internet. And then finally, AI and machine learning helping us kind of process and make sense of all the data that we are collecting and are exchanging.
I kind of see, I'm not sure if this analogy would be correct, but I kind of see when the three are working together, I see AI as like the brain and connected devices as like the eyes and ears that collect the information, and also you talked about the actual, you said there are two types of edge devices, the sensors and actuators. The actuators are the ones that implement change into their environment. So I see those as like the muscles, and like I feel like and I guess blockchain could help in making the data go from the edge devices to AI, that part seamless. Is that like a correct?
Yeah, that's a nice analogy. If we can think of sensors and actuators as the eyes and muscles, or things you could do to change something in the environment. And the AI is the brain, and the blockchain as a way of mediating between these edge devices and wherever the intelligence rests. Particularly when you have a system that is decentralized, that is spanning many different economic and administrative boundaries, then you may have to actually pay for the data, or pay for the compute, or pay for the models. And so, blockchain can help with that aspect as well as kind of making the whole interaction more trustworthy.
Okay, I'd like to focus in on each of the A, B, and C. So I guess we could start with AI, artificial intelligence. There's been much discussion about AI especially since ChatGPT released a couple years ago, and there's a lot of hype around it. It's kind of a fun question. Where do you see AI going in the coming years? Maybe like 5 years, 10 years, 20 years down the line, where do you see the technology going and how it will influence society?
Yeah, people always say the hardest thing to predict is the future, right? I think with AI in particular, this is a technology that we've actually had with us in some form or the other since the 50s.
Oh, really? Okay.
Computer scientists have been interested in how do we make programs smarter, computers smarter, machines smarter, able to kind of learn from observations rather than just from what they're instructed to do by humans. So the field has a long history, and sometimes we want to keep that in mind, that things look really exciting and cool now, but it took 60 years to get here, 60, 70 years to get here. I also think, like many technologies, AI has had its ups and downs. There are times when there was a lot of optimism behind what it could do, and then long periods of time when things seem to be kind of at a plateau. So there's a bit of this, what some people call in biology, punctuated equilibrium. So instead of sort of gradual evolution of the technology, you have sort of these moments where suddenly there's a dramatic new change that happens. And I think we're in the midst of one of these dramatic new changes. In the last, I would say, really couple of years, that the large language models have acquired what seem to be really surprisingly strong capabilities. That frankly, as someone who's worked in AI for many, many years, honestly surprised me, the ability that we saw in these large language models. But the nature of that ability really it was kind of an emergent property, where there had been previous attempts at building essentially language models that tried to predict what is the next word in a sequence of words. But getting it to the point where, because we have the compute capability today, because we can have extremely large models, because we have a lot of data that we can train these models on, all of a sudden their ability to kind of predict that next word has caused them to, or needing to predict that next word carefully or well, has caused them to almost build some model of the world, and to behave in very surprising ways with respect to how sophisticated the reasoning is behind what they're saying or how they interact with us. And I think this really was unexpected to a large extent, even for people that worked in the field. I probably trained my first neural network in 1997, so that's years and years ago. When I went to grad school, I took a course in neural networks, and remember being very excited by the topic, but also being told by other colleagues when I started out as a young academic that maybe that's a dead field, you should move on to something else.
Oh, wow.
And I think some of the people that stuck with AI and machine learning through that period of time when things were sort of at a plateau continued to work on new architectures, leveraging the new amounts of data that we have, as well as the compute power, really brought us to that next stage where we could see dramatic new advances. So if I go to Suno.ai and give it a prompt and it generates a pop song, with the lyrics, with all the music, and it sounds really good. I don't think 4 years ago, if you told me a thing like that would be available in 4 years, I'd be able to predict. So it's a very long-winded answer, which is to say I really don't know what's coming up next. But I think in the next 5 years or so, we'll probably be spending a lot of time building around the new capabilities. So given that we have these large language models, how can we use it for assistance with coding tasks in the context of engineering systems, with customer service if it's in the context of business, with personalized learning and education, and many other sort of application domains where we now have an emergent new ability. What are the new things we can build with it that can meet needs that we might have?
I see. And I guess one thing is, do you attribute most of the advance in AI we've seen in the past couple years, is it mostly the large amount of data that we have accumulated and the computer, I know we use transformers. Is that like a big part of the architecture? Is that a big part of it as well?
I think it's all of the above, right? So it was advances in the architecture, it was advances in compute, just the sheer amount of GPU hours we're now spending in training these models is nothing like what it used to be. In fact, I saw some stats that say that the compute power that we're throwing at training models is now doubling every 3 to 4 months. It used to be once, doubling every 18 months. Now it's gone down to about 3 months. So the rate of change is not only exponential, but like the rate of the exponential growth is also accelerating.
Oh, wow. Okay.
And so, compute has a lot to do with it. And because of the compute availability, we have much larger models. The number of parameters, the complexity of the neural networks that we're training has increased. And ultimately, you can only take advantage of that power if you have the data to train it. And so these models are really leveraging a lot more volume of data and increasingly multimodal data, everything from not just text, but also videos and photos and audio data as well. So I think, all of these things have had to come together to kind of to make what now seems like a breakthrough, but it's been kind of, and also these things, as I said, are kind of emergent properties. So for example, there are papers that suggest that only when our machine learning models hit about 7 billion parameters did we start to see strong performance on various metrics. That until that point, somehow the models we're building, they were promising, maybe interesting, but wouldn't be exciting, right?
Okay.
And so it's like you suddenly hit certain thresholds and new capabilities emerge.
That's interesting.
And sometimes it's hard to predict in advance what is that threshold and what is the new capability.
Oh, so like the capability you see wouldn't be linear. It's more like it's hitting a wall the whole time, and once it
And
hits
then
a
all of
certain
a sudden
parameter,
you see
it's a
something
jump.
pop up, yeah.
Oh, wow, that's cool. I guess you can apply AI to like any domain, but one domain you have been working on is education. And I want to hear your opinion on how, do you think once you learn how to use AI in the context of schools and all that, how do you think learning will change?
Yeah, one of the, I think it's called the NAE Grand Challenges. So NAE is the National Academy of Engineering. So they had 14 grand challenges they identified many years ago, maybe a couple of decades now. And one of them was personalized learning. And if you really think about what happens in the average public school classroom today, teachers are underpaid and overworked. They're managing large classrooms of upwards of 50 students, and there's just no time in their life to devote individualized attention to the students that are struggling with the material that they're expected to learn. And I think this is one of the great promises of the current generation of AI technologies, large language models and the like, that they have for the first time given us some tools to be able to really understand where each learner is at in their kind of their background, their experiences, the concepts they know, the skills they currently have, really thoroughly understand them as an individual, and then kind of systematically bring them up to learn whatever skills and concepts they need to learn at that stage. And so, I'm not saying that this is a solved problem today, but I think we now have the tools to do it. So with the type of sort of intelligent interaction abilities that these LLMs show that they have, I think this is a much more doable thing than anything we had 5 to 6 years ago. So the work that we've been doing in my lab, one of them has been kind of focused in the specific context of the problems that you encounter in math. So in particular, there are these math word problems. And it was notoriously difficult to write AI programs to understand a math word problem and to solve it and to communicate it to a learner how to go about this process. But some of the research we've done really shows that the current generation of models are incredibly capable when it comes to kind of pulling out the key concepts from something that's just verbally described, connecting it to mathematical concepts, and then being able to explain it to a learner. So one of the projects we have currently underway with undergrads as well as a PhD student is, can we build a math tutor that assesses a student, understands what they know, gives them sort of personalized lessons on what they need to learn, and then helps them when they're stuck, and kind of stage by stage and over many interactions kind of remembers who the student is and where they are, and helps them kind of become capable and confident at solving these problems.
Okay.
So that's an example of where I think AI can play a role in math education, but in other domains as well.
Yeah, I can see a future where it's kind of like Khan Academy, where you have a lecture, but then you combine it with that AI personalized tutor, where you go through problems and then it can do a one-on-one and explain the parts that you're not as good as. I have a question about how the math tutor would work. Is it only based off of a large language model, or does it also have a mathematical understanding of the world? Like, does it communicate between those two systems, or how does it
Right.
work?
At the moment, actually, we're largely just leveraging the capabilities that the top of the line models that we're getting from LLMs can give you. Depending on the subject, you may want to augment that with some additional factual knowledge about the world. Right? This is one of the big frontiers in AI. Is also how do we combine trained models or pre-trained models with some additional facts about a particular domain and the knowledge about that domain, and not just the facts but the relationship between these facts and how they're expressed, and how can we combine knowledge about a particular domain with kind of the reasoning capabilities and whatever else it might have seen in the data already to kind of further enhance its ability to explain concepts, to connect them to various topics.
Wow, it's really cool. I feel like it could be applied to almost like the communicative capacity that ChatGPT and all those large language models have with each domain. If you connect that with a specialty, it can almost do anything. And
right, and
that's
this
really great.
this thing about having some kind of a knowledge base to also draw from. Partly that is to address an issue that large language models sometimes have, which is that they're capable of hallucinating. So they can make up facts that are not real. And so to be able to kind of provide a check and balance against a set of known facts or relationships between facts, I think it helps to also find ways to combine these LLM architectures with knowledge bases.
And in doing that, do you think math will be the first subject? I feel like it makes most sense because math is so logical and formalized compared to other subjects. It might be easier to define rules and constrict it from hallucinating. Do you think math will be like the...
Yeah, I think the reason we were drawn to math as the starting subject to explore this was precisely the fact that you can detect incorrect reasoning and incorrect outputs relatively easily. And so, having a domain where things are somewhat more objective to start with, I think, made a lot of sense. But I don't think that the methodologies we're keen to explore will be fundamentally limited to that type of domain either. So maybe, eventually some of the ideas can translate over to more, say, softer sciences, social sciences, humanities, etc.
Very cool. I think you were also working on this program called ChatLang. It's called ChatLang, right? Yes. So it's like a language learning application where it's like you have a language partner, but also a tutor beside you. So you practice a language, and if you make a mistake, the tutor can explain your mistake and all that.
Right.
And I'm wondering, like, what did you learn from making that? Did you learn anything? Are there any new ideas you want to try out and the design of such a tutor in education? Yeah.
So the idea for ChatLang actually came out of my own experiences in learning languages. I learned French during my undergrad and Chinese, both in my undergrad and grad school.
Oh, wow.
And both of those experiences, I made a lot of progress because the environment was really immersive. So in the French class, you were not allowed to use one word of English at any point.
Oh, yeah.
And so kind of keeping that interaction as constrained to the target language as possible is very important for language learning. And so what I found was when ChatGPT came out, I was very excited. I can use it to practice my whatever languages I want to learn. And I quickly found that it was a language I was completely unfamiliar with. Like I was making a trip to Japan last year, and I thought I'd learn a few phrases and practice them with ChatGPT's help. If it was a language I was completely unfamiliar with, it was very hard for me to even say a few things because I needed periodically to kind of break out of role play dialogue and ask the chatbot, like, what does this word mean? Or like, how do I say this? Or like, am I saying this correctly? And so I wanted kind of two channels. And one channel in which that's completely in the target language, that's just a natural flow of dialogue in whatever language I want to learn, but then also have the ability to ask a tutor on the side, am I saying this right? What's the right word here? How do I express a certain thought that I have? and potentially for the tutor to also watch over my dialogue and give me some feedback, maybe even in real time as I'm going back and forth. And so this is hard to do in a traditional chatbot interaction because you just have that one window, right? So you don't really have two different ways of communicating with the chatbot. You just have that one window. And so Chatlang essentially just creates this interface to a large language model where you have two windows, one for your target language practice and one where you can communicate with the tutor, and the tutor can even watch over your conversation. So this is sort of the thinking behind it. One of the interesting things with that paradigm, though, is it's applicable to a lot of other settings where humans want to practice communicating with even other humans, right? So if I want to be in an environment where I have to negotiate something, perhaps I can practice that negotiation and someone can give me feedback on whether this was a good approach or not. Or what if I want to cultivate better ways of communicating that are loving, more kind, nonviolent? There's this whole framework called nonviolent communication. And can I get a system to help me, like, I want to have a discussion with someone and it has a potential to turn confrontational, but I want to keep it very, as let's say, kind and careful and, and not be too harsh to the other person. So could I use a system like this to kind of practice communicating that way and get feedback on, what doesn't work, what's a better way of rephrasing something, and would that actually make me better at communicating with other people so that I can really get my points across without rubbing them the wrong way, right? Without necessarily creating more friction than needs to be there. Or if you're a customer service agent and you're talking to lots of people, could this type of training help you be more effective at what you're doing? So I think there's lots of settings in where humans are talking to other humans, but we can benefit from really practicing these out in role play dialogues. And I think that framework for Chatlang could be applied to other systems like that as well.
Definitely, yeah. So you have the role play aspect, and then the tutor who teaches you how to do the role play.
Give you some guidance and give you some feedback. Yeah.
I can also see once the AI understands enough how maybe you could reintegrate that, and then it could step in and out of role play, and so it's more seamless. I could see that happening as well. And in addition to that, I think the speaking capabilities of AI is emerging.
Also
so
emerging, right?
We don't even need to type it in anymore. I just have to speak to the computer and it speaks back. So yeah, I could totally see that happening.
Yeah, imagine, sometime in the future kind of integrating something like this with virtual reality. So not only are you doing this role play, with a screen or with just voice, but you might actually see the person that's in the scenario. So in Chatlang, for example, you can actually describe this role play scenario. You can say that, I'm a customer visiting Japan, I'm in a restaurant, and, we're going to have an interaction. Well, imagine a nice VR experience that just goes with that. And with generative AI, I think the day is not far away where you can just come up with scenarios on the fly and just conjure up what is the VR experience that goes with it. So I think, there's some cool possibilities.
Oh, wow. Do you know, I know they're working on like video generation, but most of that is 2D right now. Is anyone working on 3D
almost certainly. I mean, there is something called NERF, which is neural radiance fields, where you can take a bunch of 2D images and it will automatically stitch together the 3D scene that corresponds to those images, maybe taken from different perspectives. So going from that to going from video samples to kind of creating an immersive VR type of experience, I think the day is not far away.
Oh wow, we're already
working on it at the moment. Okay. I'm almost certain there are groups that are exactly tackling that question.
That is so exciting. Wow. I guess good time to move on to blockchain. I feel like we've been talking about, like, I think the first time I heard of blockchain was maybe like 6 years ago or something. And I tried learning it multiple times, but it still kind of confuses me. So if you could explain to me and our viewers, what is blockchain and what are the values? Like, how does it work? Those aspects mostly, yeah.
Sounds good. Yeah, let me start with Bitcoin. So this is sort of the first, blockchain protocol. And some anonymous person or persons put it together. They gave themselves the name Satoshi Nakamoto. We still don't know who they are. But they were interested in solving what was called the double spend problem with digital cash. So, if I give you a $20 banknote, there's sort of one unique banknote with a unique serial number. It's made hard to forge, very hard for me to make another replica of that bill. But if I send you, digitally some set of bits that I claim corresponded to that bill, it's very easy for me to make a copy of it and send it to someone else. So I end up kind of re-spending the same $20 bill, which means it really isn't worth $20. And so this is the digital double spend problem. So this was the problem that had remained unsolved until the work that Satoshi Nakamoto brought to the world's attention. And so to do this in a peer-to-peer manner, they had a couple of ideas. One is that let every transaction be publicly recorded. So if I send you a set of bits, I'm oversimplifying this quite a bit, but if I were to send you a digital payment, that there's some record that I sent you that digital payment on a public ledger that everyone can see. So now if I were to try and re-spend that exact same transaction to someone else, they will say, I've seen you already spend this before, that isn't a valid transaction. So this is sort of the core idea, is that if we had a public ledger that everybody could see, they could tell when what they're getting is a valid transaction or invalid, right? And the system would be able to figure that out. Now, the next step here is that it has to be decentralized. With Bitcoin, the notion was that instead of having sort of one authority that is controlling a server where all of this ledger is being recorded, which whoever that authority is, they could censor, they could manipulate it, they could modify it, they could, be subject to attacks by malicious parties, even if they were benign. And so instead of having a central point of failure, a central, point where things could be censored and manipulated, let's make this decentralized. And that's where the sort of notion that we're going to run this blockchain on a peer-to-peer network of multiple validators that are going to validate these transactions and maintain a ledger. We need to make sure that these many different copies of the ledger are consistent, and this brings up the question of having a consensus algorithm under the hood. And so for Bitcoin, it's a combination of something called proof of work and longest chain adoption. And so there are sort of techniques there to make sure that everybody's copy remains consistent. It's very hard to modify, the copies everywhere. And so to make it sort of tamper-proof. And finally, you also need to make sure that there's an incentive for people to maintain these ledgers. And in the Bitcoin protocol, this was provided partly through the proof of work mechanism to essentially incentivize the validators that are doing the work that's needed to keep the system going. And this comes in the form of what are called mining rewards, as well as transaction fees that are paid to people that host miners. There are other blockchain protocols since Bitcoin showed up. I think that one big sort of new idea that came, for example, in Ethereum was that not only can we use blockchain systems to log transactions and other types of data, not only can we use it to then send and transact, cryptocurrencies, but also we can use a blockchain as a decentralized computer. So what that means is that, if I have any piece of code today that's running on a web server, somebody's managing that server. They could, behind the scenes, alter the computation. They may censor certain inputs. They may modify the outputs coming from the computation. But if we could do this in a decentralized computer, then we're able to kind of make that system very transparent as far as the computation is concerned. We know exactly what code is running and what the output really came from running that computation. And this opens the door to what are called smart contracts, where you can run arbitrary computations on the blockchain, and that can enable various applications from decentralized finance to supply chain systems and others. So this is also kind of another new capability that showed up shortly after Bitcoin in the context of Ethereum and other platforms that supported smart contracts.
After listening to it, I feel like the principal value of blockchain technologies is the trust that it enables. So, like in the context of cryptocurrencies, it's that if someone using blockchain, that someone didn't double spend, so you can trust that. And smart contracts. Actually, I think you talked about a smart contract mechanism that you developed.
Yeah,
Can you explain that?
So in our research, one example of something we did in the blockchain space was to develop a smart contract that allows a buyer and seller that don't know each other, and without necessarily involving a trusted third party to be able to do a fair transaction. So what does that mean? So let's say that you met somebody only on the internet and they claim to have a PDF copy of a book and were willing to sell it to you, and they quote your price. They say it's so many bitcoins worth, and you come to one of two agreements. One would be they say, well, why don't you send me the bitcoins and I'll send you the PDF. And so you send them the bitcoins, but of course this is over the internet. You're both anonymous parties, and they will just take your money and run. You're not going to get your PDF. Maybe they never had the PDF to begin with, or whatever digital good they were trying to sell you. And the other would be the next time this happens, you go, oh, no, I've seen that before. You send me the digital good first, and then I'll make the payment. And so you get the digital good, and then you realize, well, why do I have to pay them? I already got what I needed, and you abscond. So this is the thing where both the buyer and seller are worried about being cheated. And without the presence of a trusted third party, it's very hard to make these types of transactions work out. Today when you buy something, for example, there can be third-party sellers on an Amazon marketplace. You're kind of relying on both Amazon to be a trusted third party to help reverse a transaction if it doesn't go through, as well as your own credit card company. So you have these sort of intermediaries right there. But with blockchain technology, with smart contracts, it's actually possible to design a contract that allows this buyer and seller to transact with each other without requiring a trusted third party. Roughly, the idea here is that both the buyer and seller must first deposit some funds into an escrow. This escrow is just a smart contract. It's just a program that's going to lock their funds. And after this point, the seller sends over the digital good, the buyer looks at it, makes sure that they're happy, sends an approve message to the smart contract, at which point the smart contract releases the deposit of the seller, releases the payment that the buyer should make to the seller, and then returns the rest of the buyer's deposit back to the buyer. And what you can show, and what we showed in our paper through game theoretic analysis, is that the only I'm going to use a technical term here, but subgame perfect Nash equilibrium, but it's just a fancy way of saying the only sort of valid outcome for rational players is for both parties to be truthful and not cheat the other party. And it brings up a very interesting, kind of open question that we're still curious about and don't have solutions to, which is that we have a solution that will work for two parties that are, let's say, self-centered, but not for a party that's malicious. So if either the buyer or the seller were willing to forego their deposit and just to harm the other party, the system doesn't quite work. We can raise the likelihood of that happening by raising the safety deposit requirement for both parties, but then it increases too much the friction for the exchange of goods. So if I only want a $10 good, I don't want to put a security deposit of $10,000. And so, there's an interesting open question there as to whether we can also build a system that's not only cheat-proof against let's say self-centered agents, but also against malicious agents.
When I read the paper, I did not think about that, but yeah, if someone has a lot of money and is willing to lose that, they can still cheat, huh?
Right, yeah.
Yeah, I did not realize that.
But in this case, they're only interested in harming you. Their interest is not in making money at this point.
Okay, so they still won't be able to make money. It's just, they can harm you. Okay. I guess, going back to what I was asking earlier, so I feel like the principal value that blockchain brings is the trust that it enables. And I feel like the popular opinion against blockchain technologies, especially crypto right now, is that you see a lot of fraud associated with it. There was the FTX scandal a couple of years ago, and like meme coins that don't seem to have any value attached to them. I feel like people value Bitcoin and Ethereum because of the technology it brings, but there's so many other ones, and it, to me at least, and I feel like a lot of people would share my view, it seems like a quick way that people make money, but it doesn't. Most of the value of the cryptocurrency is largely speculative. They try to make money off of buying and selling it. Do you think this connects or this influences the trust we have in blockchain technology itself? And if so, how can we try to bring blockchain technology into more of a, how can we build trust into blockchain technology in this situation?
I mean, I completely agree with you. I think, the reality of what has happened in the name of blockchain over the past, 7 to 10 years, there's just been such a string of scams and fraudulent activities and various scandals that have broken out, even going back to Bitcoin and its use for illegal activities, to right, FTX and all kinds of speculative activity that's happened around the blockchain. I think it does a lot of harm to the technology adoption because it's sort of, as you rightly pointed out, like the technology is supposed to be about building trust, and these are all activities that the last thing they do is build trust. I've always talked about the need for somehow caution when it comes to making use of blockchain technologies at a stage where it's still under development. I always tell people, like, a lot of what I see happening in the crypto space is people trying to fly airplanes that are still being built, right? And that's a dangerous thing to do. So while as an academic, as a researcher, as an engineer, I see there's all kinds of interesting questions it opens up. I feel very strongly that we're still at the very early stages of working through some of those technologies. But even as we're doing it, people are putting billions of dollars on these systems, and they're learning the hard way that it also attracts the wrong kind of person to the table. People who are looking to make a quick buck, looking to cheat others, looking to run all kinds of scams and pyramid schemes. And unfortunately, a lot of the people that get drawn to some of these scams are often people who are not there for the technology. They're just there because they've heard a narrative that this is where you're going to make your fortune. So I would caution people against sort of treating it as some sort of infinite source of money that's just going to be there to help you get rich. And without fail, all of the systems that have promised to make you rich out there have largely shown to be some form of a scam at work. It reminds me a little bit of the saying by Mark Twain. He said something like, you can fool all of the people some of the time, some of the people all of the time, but not all of the people all of the time. So there's also some learning that's happening, I think. Over time we get a little bit better at differentiating between, what is more likely to be promising and what's not. My own take on it is that, AI took us 70 years to kind of get to the point where we are today. If the first Bitcoin paper showed up in 2009, 2010, we've got, another 6 decades to go. So let's go slow and let's figure these things out. I mean, not to say that we shouldn't be building systems that provide real value, but in the meantime, to be very careful of promises made as to like how mature the technology is, because I think it's still work in progress.
Do you see if decentralized finance, if cryptocurrencies become our default way of using money, our default currency, do you think it'll be more because the government implements it, or like a widespread, like grassroots movement?
I actually think it's the former. I think that people in the blockchain space tend to underestimate the effort that it took us to establish democratic forms of government that itself, it's all about decentralized governance. And, in the US and many other democratic countries, you have elections happening at every level. You elect representatives that make decisions. You vote them in or out, depending on your points of view. There's a lot of like participatory democracy that is about decentralization and trust in a system and so on. It just was not done digitally. So we don't have to throw out all of that infrastructure we've built over decades and centuries just because something new has shown up. I do think that we're going to leverage existing legal frameworks, democratic frameworks, and governance frameworks in the systems that we build. Now, there are contrary views. There are people who take a very strong position that, this really should be something that's out of the purview of governments. Government shouldn't control who I send money to, when, and for what reason. But that's not the reality we live in. It's not been the reality for a very long time. Sure, you can do very small cash transactions in an anonymous manner, but, in a traditional banking system, you send huge amounts of money. The government has, under our laws, the right to know what is that money being sent for. Is it for some nefarious purpose, and where did you get that money? Did you pay taxes on it? So these are all, these laws didn't come out of the vacuum. It didn't come from the imposition by a tyrant. It came from a democratically elected system of governance providing checks and balances against things that are fraudulent, that are people trying to take advantage of people. So these laws are meant and have evolved over time to protect us. And I think we're going to see some evolution of the legal system in the context of digital technologies, but I do think that fundamentally we're not going to reinvent what we've already done. We're going to find ways to kind of connect what we know to do well with the new ideas that we have in the space.
Okay. So when we use cryptocurrencies right now, it's supposed to be anonymous, and no one's supposed to see what you use the money on. But when it would be adopted, you would think that the government at least would be able to check in on that.
Yeah, and they already do. So
They do.
in the sense that even if you're anonymous in the world of cryptocurrency, the on ramps and exit ramps to from fiat currency to cryptocurrency and back are generally controlled by existing laws, right? So there are financial regulations that apply to the various brokers that are helping you convert from fiat to cryptocurrency and so on. So I think there's already quite a bit of check and balance in place in terms of like going from our traditional forms of currency to cryptocurrency. Within the cryptocurrency world, people kind of underestimate, at least the systems that are out there today. They overestimate how much anonymity it provides, because there's quite a bit of information you can draw from addresses interacting with other addresses as to which ones are engaging in risky and malicious behavior, and so. So I think it's not that it's a completely anonymous world if you're sending Bitcoin. There's quite a bit of tracing of Bitcoin transactions that can be done and is being done actually, and I think honestly it's a good thing. I think we want to build systems that solve real problems. I think one real problem we could solve with cryptocurrencies and stable coins is making it possible to send significant amounts of money over long distances, maybe across administrative boundaries, relatively quickly, and just do these settlements very quickly, right? With a traditional bank system, sending money abroad sometimes could take weeks to settle, but you could do that instantaneously with blockchain technology. So there's something good there that we want to keep, but there's also potential for harm if we make these things completely unregulated. So the funds could be used for money laundering, could be used for various illicit activities. You want to try and limit that type of negative outcome. So I think it's going to be about striking that right balance between the usefulness of the technology and the harms that it might bring about if we don't regulate it.
And for right now, when we send money, like say abroad, do we send it through a third party? Is it similar to the smart contract situation where the blockchain technology would enable us to do peer-to-peer, and the algorithm
that's the short
essentially
version of it. Today's systems take a long time to settle because it's sort of many different banks and intermediaries that might be involved in that process, and just their systems are very archaic, and some of it is quite manual still, and so on. Whereas blockchain would be a peer-to-peer system, and and ideally, whatever transactions you're making are still transparent. They're still checked against for the validity of the transaction, that it's not a double spend transaction, for example. But also, I think ideally it would also be checked for compliance with laws where they exist.
Okay. And who would be running the algorithms and maintaining it? Would it be, I guess it's distributed ledger, so I guess anyone, but is the idea that you get incentivized to do it? Is it like the proof of work?
Typically miners or validators in a blockchain system, people that are hosting these nodes that are part of the peer-to-peer network, they are going to need some kind of an incentive for the work they do. In the traditional blockchain systems like Bitcoin, that work they're doing is quite heavily computational, and so they're spending electricity to run the miners, for example. And so whatever it's costing you in electricity to run the miner, you should hope to be paid at least more than that for you to want to do this, right? Just economically, otherwise it's a very irrational thing for anybody to run a mining rig. So in the Bitcoin system, for example, there's an economic incentive that comes from something called block production rewards, where miners are engaged in the task of solving something called the proof of work puzzle. And if they manage to solve it first, their block gets sent to the rest of the nodes in the network. It gets added to the blockchain. And at that point, they will receive what's called a mining reward. In addition to that, every transaction that they include in the block comes with its own transaction fees paid by whoever's sending those transactions. So if I'm sending I don't know, $100 worth of transaction to someone, I might put in a $2 transaction fee to go with it. Think of it as a tip that I'm offering. And roughly speaking, what happens is these miners are greedy. They look at who's offering the highest tips and they include those transactions into their blocks. So the more tips you offer or the more transaction fee you're offering, the quicker your transactions get into the chain. Again, newer systems have looked at various variations of this, including where, for applications built using smart contracts on the blockchain, can we get it so that not the people sending transactions, but the people who are running these, who deploy the smart contract, and we get them to pay for all of the costs associated with running that smart contract and processing the transactions associated with it. And maybe out of band, they have other ways to recover money from running that application in a decentralized manner over the blockchain. So yeah, definitely there's a whole kind of rich field of crypto economics that's all about, how do you incentivize all of the players in the system, people that are running the miners or validators, people that are developing and deploying smart contracts, your end users, to all kind of be together and work on both the what's called layer one of the blockchain as well as the applications themselves.
This might be a stupid question, but is there a possibility that a centralized, maybe like a public organization, maybe the government runs the blockchain and the mining that goes with it, or is that like antithetical to what blockchain is?
So there is something called a permissioned blockchain, where you can have a set of organizations. These could be government agencies at different levels, right? It could be federal, state, as well as city level, running nodes, and they're kind of authorized to run the nodes, and only these authorized parties can run a blockchain node. And I think there could be use cases for implementing a blockchain that is permissioned in that way. For example, perhaps to provide identification documents that are digitized. So perhaps our passports could be on a blockchain, and this could be something that is a government-run system, or our driver's licenses could be issued by a system like that. But I also think that there is, among some section of the population, some distrust of a system that's entirely permissioned. And this has been the attractiveness of protocols like Bitcoin and Ethereum, that they're open enough that anyone can run a node on a chain. There are checks and balances against how much damage they can do to the whole system because of the way the protocol is designed, but fundamentally it doesn't limit anybody from starting a node and running it. So I think we're going to see both systems in the long term. We'll see some applications that need permissioned blockchains, perhaps either in part or wholly owned by various government entities, and we'll also see permissionless blockchains have a role to play.
Wow, okay.
We unfortunately ran out of space on our SD card, and the last 15 minutes of our conversation was cut off. In those last minutes, Bhaskar discussed the future applications of connected devices, hurdles we have to overcome for the implementation of smart cities, and gave young students like me advice on life and how to remain curious and retain that sense of wonder. Hopefully, we'll get to talk again, and hear his perspective on topics we did not get to today. I want to thank Bhaskar for making the time to have this conversation and enlightening me with his thoughts on emerging technologies. I learned a lot and hope you all did as well. From Studio A at the USC Annenberg School, this was Tyche Jones, your host from the Paradigm Podcast. We currently publish our episodes on YouTube and Spotify. If you enjoyed our conversation, please consider liking and subscribing. Thank you all for listening.